Well, are we done? I mean, here we have a picture. Here's one of our stripes now. And if you think a little bit about how the stripe works, you can see, in fact, we have 4 copies of, again, the same hardware. Right? One of our little individual building blocks now. We have 4 copies of that. Is there a way, for example, in which I could sort of reuse that 1 copy n times to do a stripe's worth of work, and then redo, keep iterating once again to get all the different stripes I need? So this is what's called bit serial multiplication. You build hardware that basically can do, 1 bit of multiplication, and you basically keep track of all the other intermediate results and feed them back into the circuit using registers. And what we can see here is that the sort of ridiculous extremes department is I can get the hardware cost to near constant, assuming for other reasons, I still need to hold all the bits, the partial products and things like that. And often the registers we need to do that are available because we capture the results, the incoming operands and the results going to other parts of the circuit. And we can reuse those registers to remember partial answers as we're busy computing the result over many cycles. The latency is much longer now. The latency is now n squared, because we have to reuse this piece of hardware n squared times. Okay, but the size is really very, very small indeed. So if I put this all together, here's this little table. So this is the comparison shopping that Consumer Reports will put up for you, showing you all the different options you have for buying multipliers, right? We have a combinational multiplier, and you can sort of look and you can say, well, that's in a sense, that was the naive approach, the one that maybe we would have designed without thinking about it. But it turns out there's a lot of trade-offs we can make, some of which are, just sort of better. Like the end-stage pipeline has about the same hardware cost, the same latency, but much better throughput, so forth and so on. So this is sort of neat. This big trade-off that you have to do is the sort of trade-off that most of you, if you go into engineering of digital systems, you'll be spending a lot of time thinking about these trade-offs. Saying, is there a way I can, with the same hardware, perhaps running at a slightly higher clock rate, that I can dramatically reduce the size of the thing? Instead of having an entire rack of electronics to do MP3 decoding, could I in fact make it so small that I could put it in a tiny little device and sell it, put an I in front of it and sell it for, make the world's most valuable company? So these sort of trade-offs are sort of fun, and they actually have, a real impact on the engineering that you'll do.